Now, good day. Welcome back to our Post 1 tutorial. If today is the first time you're visiting my channel, make sure you tap on the subscribe button, put the notification bell to on, so that anytime I upload the video, you'll be the first person to get it. Yes, this is your brother Apostle Daniel, and make sure you share. Now, at this particular point, I'm coming to talk about special angles. Yes, now, of course, when you talk about special angles, you're talking about this particular angles. Now, talk about angle 0 degrees, 30 degrees, 45 degrees, 60 degrees, and then 90 degrees. Now, these are the special angles we are looking at. Now, this is what we call the special angles, yes. Now, as trigonometry is concerned, whenever they give you a particular question at the special angles and the angles are these particular questions, you don't have to be thinking, because it is something that's supposed to be at your fingertips, yes. It is something that's supposed to be at your fingertips, yes. Yeah. Now, after that, we will talk about other angles, but these angles you're supposed to know, yes. Now, in one of the questions I saw in the assignment, yes, we had to derive the sine 45, cos 45, and tan 45 using a square of side 1 unit. A square of side 1 unit. Now, we have so many ways we can prove this 45 degrees. In the next video, I'm going to talk about how we can prove 30 degrees. But for now, let's talk about a square of 45, a square of side 1 unit. And this one is part of a particular assignment I saw somewhere. Now, let's consider a square. Now, assuming this one is a square, where the side is 1 unit. You know, when a square has a side of 1 unit, it means that square has all the sides to be 1 minute. 1. Don't forget, here is 90, here is 90, here is 90, here is 90. So 1 unit means here is 1, here is 1, here is 1, and then what? Here is 1. This one is a square, yes. Now, how can we get an angle 45 degrees? Now, I can convert this one into a right angle triangle. Now, just indicate a straight line from here to here. Now, don't forget that if you have a square, then you draw a diagonal like this. If you have a square, then you draw a diagonal like this. The diagonal divides the edges here into 2 equally. Yes. Now, another thing you can also consider is that, now when I consider this particular triangle, the diagonal divides into 2 triangles. That makes it what? A square. Yes. Now, this place is 1, this place is 1. And don't forget that the moment this one is 1, this one is 1, it means this side and this side are equal, right? Now, since this side and this side are equal, then we can guess the particular type of triangle is this when we consider this, or even this. Now, this type of triangle becomes a right angle triangle. A right angle. This one becomes a right angle. So the whole triangle becomes a right angle what? Triangle. Now, it is not just a right angle triangle. Can you see that this side and this side are the same? And then when we consider the particular types of right angle triangle, this one will be an isosceles right angle triangle. Why is it isosceles right angle triangle? It is a right angle here, but since this side and this side are the same, then it means that this triangle is also isosceles triangle. So we're going to call this one isosceles right angle triangle, with where the equal size is 1 unit. Yes. Now, since we have isosceles triangle, it tells you that for isosceles triangle, this angle and this angle is supposed to be the same. So if this angle is angle theta, okay, now let me use a different angle. If this one is angle A, then here too supposed to be an angle A. You understand? Yes, for isosceles triangle, it means 2 angles are the same. So if here's supposed to be A, here's supposed to be A. Now let's come back to this particular square. Now, square has all the angles to be 90. And then these angles are the same because the diagonal here will divide this angle into two. So therefore, here becomes 45 degrees. And then this side also becomes 45 degrees. Yes. So it means that we will have a rectangle triangle like this, where this side is 1 unit, here is 1 unit, here will be 45 degrees, and then here will be 45 degrees. I hope it's clear. Yeah, very good. Nowadays, the diagonal here becomes a hypotenuse. So we can easily find a hypotenuse, you get it? Now let me consider this side to be M. It means this side is also M. How can we find the hypotenuse M? Or the diagonal M? Don't forget that the hypotenuse square is equal to opposite square plus what? The adjacent square. Don't forget that the hypotenuse is now M. Is this side M? So we have M squared is equal to, now opposite to be 1 squared, adjacent to be 1 squared. So we're going to have M squared is equal to what? 1 plus 1. M squared is equal to 2. So M will be equal to root 2. Now we can talk about plus or minus 2 here, but for this particular diagonal here, we can't get a negative diagonal. So I'm going to consider this one as the root 2. Now root 2. Now look at it very well. Look at it carefully. Look at this one carefully. Now, for this particular right angle triangle or this particular square, we can find the sine 45. We can find sine 45. Now, what is sine 45? Don't forget that we are using so, ka, and then twa. If you don't solve the, go and watch the previous video. This one will be very difficult for you to understand, right? Now let me consider this particular angle 45 degrees. The sine is opposite of a hypotenuse. So the 45 degrees, the opposite is 1 over hypotenuse. Hypotenuse is M. The hypotenuse is root 2. So we're going to have root 2. And don't forget that we can rationalize this one. Yes, when we rationalize, we're going to get multiplied by root 2, multiplied by root 2. We're going to get root 2 over 2 when we rationalize. Yes. Now, let me tell you something. In the previous video, I talked about complementary angle, right? So it means that sine 45 is supposed to be the same as cos 45. Because when you subtract 45 from 90 degrees, you're going to get what? 45, right? So with this one, we have to get the same answer as sine 45. Yeah, so the cos 45 should be the same as sine 45. Now let's look at cos 45. Now, what is cos? Cos is adjacent over hypotenuse. The adjacent here is 1. The hypotenuse is the same root 2. Don't forget. Multiply this one by root 2. Multiply this one by root 2. We're going to get root 2 out of 2. Have you seen that the sine 45 and cos 45, they add up to 90 degrees and we are getting the same answer? Yes, they are complementary angle. Now, the last one, let me talk about tan 45. Now, what is tan? Tan is twa, and then the twa is opposite 1 over adjacent 1. 1 over 1 is 1. So this one is so simple. It means that when we have sine 45 the same as root 2 out of 2, cos 45 is the same as root 2 out of 2, tan 45 is 1. You see how simple it is? Yes, it's very simple. Very, very simple. Now, because of that, you can also look at the sec 45. What is sec 45? Don't forget, sec is 1 over what? 1 over cos. 1 over cos. So, cos 45. So, what to be sec 45? We need to turn this one upside down. You get it? We need to turn this one upside down. Turning this one upside down, we're going to get root 2 out of 1, which is the same as root 2. Now, the same way, we can talk about cosec 45. Cosec 45. Cosec 45 is what is 1 over what? Sine 45. So what does it mean? We need to turn this one upside down. Turn the sign upside down. So we're going to get the same thing, root 2 out of 1, which is root 2. And don't forget that the sec and the cosec are also what? Supplementary angle. Now this one is not part of the solution. I'm just adding it. Now let's come to cot 45. Don't forget cot 45 is minus 1 over what? Tan 45. You understand? And then tan is 1 over 1, and 1 over 1 is still 1. So that is how the thing is. It's very simple, yes. It's very simple. So the answer to this one is, this is how we can easily prove it. Thank you very much. Let's meet in a different video. I'm going to talk about how we can prove the other trigonometry ratios. Yes. Bye-bye.